Today we are adding in variables on both sides, but with inequalities, and that is going to be on page 40. Okay, and then we have 2 pages, so our title page is going on the left and then our other page on the right. So go ahead and pause it if you need time to add that in or to glue. Okay, so when we are solving inequalities with variables on both sides, there are inequalities that we will solve where we'll get answers that look like just normal inequalities that we've got. Now, if you forget all of your rules about what we're doing when we're solving, if you flip back in your notes back to page 30, this has all of those steps that we're going through each time. So just like equations, just like we said with the notes with multi-step inequalities, right? We're still using the same process. This still works exactly the same. Okay, so if we go through here, the first thing we say, are there parentheses? No. Are there like terms on one side? No. Are there variables on both sides? And our answer to this one is yes, right? We have a variable here and we have a variable here, right? And when those variables are on opposite sides of the equal sign, or in this case, inequality sign, we get them together using the opposite sign. So since those are on opposite sides, we need to move one of them using the inverse operation. Sorry guys, apparently I have the hiccups. So if this is a positive 2w, right, we're looking in front, we are going to move that with a negative 2w. And we are putting that underneath both of those variables. So 2w minus 2w cancels out. That leaves us with a negative 9. 8w minus 2w gives us a 6w plus 11. Okay, then we will undo, there's no large fractions, so we'll undo any addition or subtraction that we see. So we will undo adding 11 by subtracting 11. And then we will undo our multiplication with division. So we are dividing by positive 6. If we are dividing by a positive, we do not flip the inequality sign. So our inequality sign is staying the same, but we do want to get this in its simplest form. So I'm going to turn this into a negative 10 over 3. And all right, we've talked about this. Really our best usable way to deal with an inequality in its final form is to write this with the variable first. And rewriting with the variable first is a reason to flip that inequality sign. So whether you write this as negative 10 over 3, negative 3 and 1/3, negative 3.3, repeating, you have to have that repeating bar. Any of those are fine as long as you do not approximate. Man, these hiccups in this video, sorry. So our second one, right? We're going down that list that we've always used. If there are parentheses, so we need to distribute, right? We don't see the one sitting there, but it's really there. So we're going to distribute a negative 1 to each of these. So negative 1 times 2 gives us a negative 2x. Negative 1 times 1 gives us a negative 1. If there are like terms, we want to combine them. So if we look over here there are like terms. So we want to combine those. So a 5x plus a 3x gives us an 8x. No like terms to combine over here. Okay, our next step says if there are variables on both sides. Okay, so up here, this 5x and this 3x, right? These are on the same side. So we got those together with the same sign. These are on opposite sides, right? My inequality sign is here. One is on the right and one is on the left. So we need to get those together with the opposite sign. Normally we can move either one, but here we really want to be moving this negative 2x because we don't want to empty this side. If we move that 8x, there's nothing left, and that's not good news. So we'll undo a negative 2x with a positive 2x, right? We're writing that once underneath each of the variables on both sides. 8x plus 2x gives us a 10x, so the negative 1. We will then undo multiplication with division. We are dividing by a positive, so not a reason to flip the sign. We'll get x is greater than negative 1/10. Now, just like when we did solving equations with variables on both sides and some weird things came up, that same thing can happen when we are solving inequalities with variables on both sides. Okay, so sometimes our variable is going to be canceled out. They're going to cancel each other out. And we will be left with a true statement. Right? We talked about this idea before. If we flip up here previous in our notes, right? We said that that idea of getting a true statement or a false statement, that idea still applies when we're looking at inequalities. Okay, so same steps. If there are parentheses, we distribute. So we see those parentheses. So I'm going to distribute a 3x plus 18. My other side stays the same. There are not any like terms to combine, but we do have variables on both sides. We have one here and we have one here, right? Those are on opposite sides of the inequality sign, so we want to get them together with the opposite sign. So I will move a positive 3x by subtracting 3x. 3x minus 3x goes away. That's nothing. So we're just left with 18. 3x minus 3x also turns to 0. So we're only left with negative 1. Now the key here is that we are looking for a true or a false statement. Not if the numbers are the same, if the statement is true. Is 18 greater than negative 1? Okay, and that it is a true statement. So when the statement is true, okay, the answer is going to be all real numbers. So same thing that we had before. When we got a true statement, we get an answer of all real numbers. Okay, so if we look at our second one here. So step 1 says, if there are parentheses, distribute. So we do have parentheses, so we're going to look directly in front of the parentheses. We don't want to look any further than what number is sitting right in front of it. So we're only focusing here. None of this matters for the time being. Okay, so I'm going to distribute this 1/2. 1/2 times A is 1/2 A. 1/2 times 8 is a 4. Everything else is coming straight down. This is a positive 1/2 A. Okay, step 2 says if there are like terms, we want to combine them. No like terms over here, but we do have like terms we can combine here. Okay, so 3 plus 4 gives us a 7. Right, those are on the same side, so we are combining them with the same sign. Okay, our next step says if there are variables on both sides, which there are now variables also on both sides. So we have it here and here. Right, these variables are on the opposite sides, so these we are using the opposite sign for. Right, one of the A's is on the right and one of the A's is on the left. So we'll move a positive 1/2 A with a negative 1/2 A. Those just cancel, and those cancel. So we're left with 10 is greater than or equal to 7. Well, is 10 greater than or equal to 7? Yes, it is. That's a true statement. So our answer is all real numbers. Sometimes our variable will cancel out and we will end up with a false statement, right? We have that same idea with equations. So if we look at this, there's no parentheses, but there are like terms we can combine. Those are on the same side, so we're going to use the same sign. 2h plus 8h gives us 10h. Right? No like terms to combine on the same side, but we do have variables on both sides. So opposite side, we are using the opposite sign. I'm writing it once under each place I see that variable. So 10h minus 10h just cancels out. I'm left with negative 5. 10h minus 10h cancels out. I'm left with a positive 3. Okay, so again, we're asking ourselves if it's true or false. Is -5 greater than 3? No, right? That's false. So when this statement is false, the answer is a no solution. Okay, so false statement, our answer is no solution. So look at our next one. We do have parentheses, so we are going to distribute. No like terms, but we do have variables. Those are on opposite sides of the equal sign, so we are going to get those together with the opposite sign. Okay, so we have an 18 and an 18. Now we have to be really careful here because 18 is not less than 18. If this said 18 is less than or equal to 18, that would be a true statement. But this does not have the or equal to, so this is a false statement, and therefore we will put no solution. And then finally, right, we are just continuing this process that we should be able to justify and explain our steps. I know it's all of your favorites. It's something we need to be able to do, though. Okay, so if we look at here, first thing, are there parentheses? Yes, there are. So we could distribute. So if we distribute, that becomes a -2n. A -2 times a -5 becomes a +10. Okay, so for our first step, what did we do? Right, what we did. I distributed -2. Then we're going to put the where. Oops, I don't need that. To both numbers in the parentheses. Why did we do this? We did this because we need to simplify to get rid of the parentheses. I guess I should write out the word parentheses, and I drew them up there, but. Okay, our next step. We have variables on both sides. So we'll use the opposite sign, right? Opposite side, we're using the opposite sign. Okay, so what are we doing? I added 2n. Now we might need to be a little bit more careful here because we don't just have this other side that's empty, right? We're adding it to both sides. Okay, but we might even include under like where the variable's written, right? Under each variable. Because this part is the same, right? How do we undo a negative with a positive? So, right, it still is sort of that inverse operation, but because we cancel a negative, with a positive. And our goal here isn't really an inverse operation. Our goal here is to get one of these variables to cancel out. We're trying to get one of those to become 0, right? That's our objective of why we combine those together. Okay, but now in this situation, when we bring this down, our 2's actually end up canceling on both sides. So we get 10 is less than or equal to 10. Is that a true statement or is that a false statement? Well, this is true. So we get an answer, or I get an answer. Of all real numbers, because 10 is less than or equal to 10. Right? This is true, so our final answer is all real numbers.